Now, to look more deeply into the pipeline, the network system for making masses of information available to the electronic book. Using a single video carrier, we have a signal the entire country is already set to use through television sets and video recorders. That carrier can be broken down into 75 separate subchannels, each operating at 20,000 cycles per second. Using one subchannel, if we set the data density again at 2 bits per cycle, we get 40,000 bits of data per second. This again applies to only one of 75 subchannels on a single video carrier. Using the same techniques as cable television operators, 80 such carriers can be loaded into one video cable, offering 6,000 channels of distinctly separate text in the same cable at the same time. Picking out any specific information channel from these 6,000 simply calls for reversing the whole process. By using the same computer chip found in televisions or video cassette recorders, the electronic book can call for any of the 80 video carriers. Once that carrier has been selected, the process is repeated with a similar chip that operates in the frequency range of the sub-channels. In those two steps, any of the 6,000 sub-channels can be accessed for loading into the electronic book. The information distribution capability of the pipeline is clearly phenomenal. 6,000 signals, each with 40,000 bits of data per second, adds up to a system capacity of 1.4 billion bytes of data a minute. The pipeline system could offer a school campus a complete library on videotape. It could give a hospital wired with cable in every room an ability for instant staff access to needed data. A cable company could become a wholesale distributor of information or a publisher in its own right. And an industrial complex could have information available economically to all its employees.